Hello, I'm Sylvain Moulera from Teruco, and here I will present you the results and tools we developed last year in the OCAPI project, which in English translation would be Biodiversity Observation thanks to more intelligent cameras. The OCAPI project is developed by Teruco in collaboration with civil engineers working on autonomous vehicles from the Gustav Eiffel University and ecologists from the Functional and Evolutionary Ecology Center. The initial project has been granted by the Ferrec Foundation, which is a foundation of the major French civil works companies, and now it's pursuing its grant granted by the French Program of Investment for Future. The OCAPI project was developed around the idea that, in the one hand, more and more sensors and particularly cameras are deployed everywhere in the territories, and in the other hand, that the fight against the sixth extinctions requires massive, large-scale monitoring of biodiversity. In addition, automated recognition systems are fastly growing in the field of ecology. So in the OCAPI project, at its early beginning, we would like to opportunistically use existing sensors around transport infrastructure to perform risk analysis of collisions with large ungulates. Thus, the idea was to use existing sensors as permanent static field workers able to recognize the main species involved in collision with cars or trains, thanks to convolutional neural networks, and then to use this presence information to perform occupancy models in order to map the presence risk of our targeted species in the vicinity of the transport infrastructures. Unfortunately, everything goes wrong in the project and we had to change a lot of our initial plan. To perform the OCAPI project, we first planned to test and, if necessary, train existing neural networks able to recognize our main species of interest. In both these cases, we needed labeled data sets for tests and developments. Here starts the problems. To be sure that our recognition ability fits with their operative use, we contact data managers operating close or in transport infrastructure, and most of them condition the data sharing to the fact they will be able to choose with whom they'll later share the data. So the full open data option couldn't be used. Unfortunately, most free existing platforms devoted to deep learning are poorly able to manage this kind of data and do not allow for complex data sharing management. So to not kill the project at its early beginning, we developed a new collaborative web platform dedicated to the development of deep learning technologies for biodiversity. The OCAPI platform has three main functionalities supporting the development of artificial intelligence. First, a data storage and management function, where the user can store its data, choose if they are open for other use or not, and manage with whom the data can be shared. Once the data are uploaded on the platform, they are analyzed by existing neural networks, which allow us to blur human faces and to pre-identify some elements such as human, cars, trains, horses, cows, etc. Then the data are ready for the second functionality, which is the labeling. The platform provides tools to label images, sounds, and soon videos with bounding boxes around species of interest. The labeled data are then stored and ready to be used to develop new neural networks. In this respect, the data scientist can download the labeled data. So at that stage, we thought we saved the project and finally obtained an initially unexpected performance tools for further projects. But not yet. Due to turnover in teams in our transport infrastructure partner, we lost our ability to use existing cameras on the transport infrastructure. So we changed our plan and thus worked on simulated data rather than on real ones. By chance, we worked with SNCF Réseau since 2018 on the reduction of risk collision on the region Occitanie in France. In this respect, we use metapopulation dynamic simulation of ungulates to identify collision hotspots, and then propose and test mitigation measures and for 5 sites. We designed a monitoring experiment to test the measures' efficiency based on camera trap deployment. Thanks to this work, we had some material to work on simulated data instead of real expected one. Here are the results of the metapopulation dynamic simulation of ungulates, where yellow represents highly frequented places thanks to the simulation results, and dark blue ones are the less frequented ones. Sorry. In blue and green dots are the proposals for camera trap deployment on the field. Based on these informations, we divided the space in hexagonal cells, where the colored ones are benefiting from at least one camera trap, and for which we associated an observation effort increasing with the number of cameras in the cell. The color gradient, as for the previous map, reflects the number of individuals visiting the cell during the simulation. We then used usual detection probability of camera traps function to simulate in each occupied cell a 10-session history of ungulate detection composed of blue detection occurrences and red non-detection occurrences. We finally, based on this data, perform an occupancy model selection, considering that the observation effort and simulated frequentation may play a significant role in the occupancy probability prediction. Here the main result is that our occupancy model prediction is coherent with the population dynamics simulation, meaning that first, the global procedure once used on real data is expected to provide relevant useful map of species occupancy, and therefore risk of presence of our focal species. And second, that our camera trap-based sampling design is sufficient to catch the spatial information at our study site scale. To conclude on the OCAPI project, even if things didn't happen as expected, we have been able to develop the full process and automated analysis starting from the camera trap and providing a map of the collision risk. And in that sense, we roughly reached our initial objective. Unfortunately, this only had been applied in a theoretical arena. From a less technical point of view, the development of the OCAPI platform initiated a national dynamic which sustained the platform development and its functionalities. And we are expecting that this dynamic will support the next developments, which are mostly already granted. First, we will apply the OCAPI framework on the data issuing from the mitigation measures monitoring to implement it on real data. This is something running for the next 5 years, with the first dataset available in 2023. Second development will be the implementation on other cameras associated to transport infrastructure. Indeed, here we use the biodiversity monitoring system with cameras of good quality, the ability of using up to 30 cameras on a limited space, but this is an ideal case, and all the transport infrastructure are not benefiting from such dedicated sensor networks, and we want to use it on more realistic ones and more general ones. And third, which is more a longer time expectation, is combining multiple networks of cameras to use it for developing large-scale monitoring systems. In that sense, we can couple, for example, cameras on transport infrastructure with others coming from cities or any other networks of cameras. This is the long-term idea of such developments. Thanks for listening.